Hey, so we had to do an emergency repair in the number 5 crossbar earlier this week. And to understand the repair, we have to talk about the dreaded green goo that we find all over that switch. This goo is well known to switching people, so if you're into, telephone switching or key systems or anything like that, chances are you've experienced this goo before or you've heard about it. Now, it usually comes from potted relays like this. This is a potted relay. This is not the only kind that you'll encounter, but this is the one that's being problematic for us. The technical name for this is a 316 type relay, but essentially what it is, it's a glass envelope right in the middle, and I can't take this apart, unfortunately. It's a glass envelope in the middle, in between this TIE fighter looking thing. So inside you have these two rectangles, and between the two rectangles is a sealed envelope full of mercury. Well, not full of mercury, but it's got mercury in there. And then there's two contacts that close like that, like a little reed. And wrapped around the envelope, again in the middle of the little TIE fighter shaped thing, is the coil of the relay. And when you energize the relay, it operates and does the fancy thing. Our number 5 crossbar, especially marker number 0, which is the wire spring marker, uses these relays extensively. And they leak. And when they leak, the green goo gets all over the relays below them, which are not this type. They're actually completely exposed. And it causes them to not operate. Now, we mitigate this sort of by cleaning the marker at intervals and checking these relays that are potted to make sure that it's not causing a problem. And we put trouble cards underneath the leaky relays, so we could put them on the mounting plate under the relay. So if it does leak, it just leaks on the trouble card, and it's not a big deal, and we can change out the trouble card and it's fine. But in this case, there was 1 or 2 of these that were leaking that did not have a card under them, and the leakiness got onto the relays below. And those relays are really important. Specifically, they're important for trunk selection in the marker. And trunk selection happens on every call because the marker has to be able to pick out of the choice of this many paths that I can use, which path am I going to actually use. So that's trunk selection, and it's critical that these relays operate when they're supposed to. So why do these leak? Well, my best guess is this. These relays, these potted ones, were designed to replace an earlier design. In fact, our other marker, CM1, or completing marker 1, doesn't use the potted relays. It has these. These polar relays have been around forever in the Bell system, and they're used everywhere for all different things. They're actually really versatile, and depending on how you wire them, you can make them do all kinds of interesting stuff. In the marker, these are most often used for cross detection. So you can bias them in one direction, and if there is a cross, like on this side of the relay, there's a cross to battery or a cross to ground, this relay will operate because of the increased current flow to the cross, to the point where there's a short. And if there's no cross, the relay won't operate because there won't be enough current traveling through it towards the source of the short to ground or whatever. That's the 2-minute description of how these work. They use them in all sorts of complicated ways. So these relays are great, but they are relatively high maintenance. There's 4 little adjusting points here, 1, 2, 3, and 4 in the back, and they need to be biased, and each one has its own little feelings. And I think at some point, in the late 60s, Western Electric or Bell Labs decided, hey, why don't we replace these things with these? Because they come pre-adjusted from the factory. We can make them in any characteristics we want. And if it goes bad, you just pull it out, put a new one in, and then you're good. Cool. So they designed these to last for 20 to 30 years, which is fine, because if something goes bad, you order a new one from Western Electric, they ship you a new one, you plug it in, and you're good to go. From an operating perspective, can't beat it, right? Our number 5 crossbar is very old. It's that completing marker 0 is from like the early 1960s. Without looking at it, I don't remember. And we are well in excess of its design life. And, you know, I bet that they just didn't do 60 to 70 year life tests on these because they didn't have to. Anyway, this green goo is leaking everywhere. And the trouble cards under the relays are a super effective way of keeping it in check. And it's worked so far, except in this one instance where we forgot. So, here's what we did.
At last, a task I understand. Goop. Bad.
Let me see the goop.
Oh, okay. Here.
Ugh.
Gross. It must leave. Be gone.
These are the trunk selection relays. These need to, when you have a trunk group with, you know, trunks that go somewhere, the marker is going to pick a trunk from the group. These relays operate to pick the actual trunk that's in the group. So here's TSO. That's how it feels. It's very snappy. TS1 has some goopy on it, which you can't really see back there. And it's very, it's gross. Turn the flash on. See the goop in there. Claire has already scraped most of it away, but it's gotten into the guts of TS1 way down in there and underneath it. And now I have to take apart TS1. No.
Look how much goo I got in one go. This is the most yet.
Wait, I gotta focus on it.
Okay.
Wait, don't move.
So, I don't know if the viewers have ever watched someone make hard candy before, but it's very similar to that.
Ugh. You can see that for a second?
Yeah.
Goop.
I also found a very distinct, harder and yellower goop over here, which was particularly disgusting to remove. Quite unpleasant. Also, it keeps ripping the paper towel to try and get rid of it. And it got my hair in there because I'm just trying to like scrape along this very tiny row so I can't get anything out, and I got shocked.
Now, the goop is awful and it sticks to everything, and you can't remove it with regular soap and water. You need Goof Off or some other, you know, high-powered, high-octane cleaner to get it off of you. And it'll stick to your gloves, it'll rip your gloves. It's just like, it's impossible to work with. So I just took a razor and some Goof Off, and then I did like a rag and some Goof Off to get these all clean, all the while Claire was cleaning up the marker itself. The next thing we had to do was take out the affected TS1 relay. Now that was a standard wire spring relay, totally exposed, and that was the one that was sticky and bad. So nobody knows what this green goo is. This has been the bane of telephone collector people forever. You should probably send it off and get it looked at. Anyway, this is the back of TS1 here. Ooh, exciting. And just got to remove all of these wires. This is the form that goes out to elsewhere. And then there's the local cable, the green stuff here. Time to pull off some of these guys here. I've already busied out the marker, so we shouldn't be getting any calls through this marker. And these, like I said, these colored wires will be easy to put back on because they're going to be obviously labeled in the schematic, and I have pictures. The green wires, which are the local form, that's just the form for this mounting plate. Those are shop assembled, and that's why they don't use colors, because this was as part of the cost reduction for this switch, for the number 5 crossbar in general, which was supposed to be a less expensive thing than, say, a number 1 crossbar. They didn't do all of the wires in these forms like this in the shop. So in the shop, they did per mounting plate or per set of mounting plates, they used the same green wires and they just zipped them down as quick as they could. And then for the wires that have to leave this form, they use this and they leave on this big spine here, right? Not good or bad, there's no value judgment there, it's just that's how they did this one. In the number 1 crossbar in the panel, all of the wires would be brought out to this form, even if they were just going to the next relay over. So you leave the relay, come to the form, go through a stitch, and go back in. They didn't do that with number 5. So anyway, 12, 11, 10, wait, 12. So I'll just label those. And I'm just gonna do this process for the next, however many minutes. And after we got it out on the table, so I didn't really get a lot of the disassembly process, because this was actually a really frustrating job to do. And I ended up having to get up and wash my hands a bunch, and then get up and try different gloves, and the gloves kept tearing and breaking. And then we ended up eating dinner in the middle of it because we were just hungry. So there wasn't really a nice, clean sort of tear down portion of this video. I just videoed what I could and then did the rest off camera. It ended up taking me like an hour and a half to get the whole thing apart and then cleaned. Cleaning it was like this 3 or 4 phase operation where I got most of it clean, but by that time my hands or my gloves or whatever were completely sticky, so I had to go wash them and then come back and re-clean everything because I'd gotten sticky everywhere else. So it was just sort of like, it felt a little bit like pushing the goo around rather than actually making any serious progress on getting it clean. But eventually I did get it clean and I started putting it back together, and I got it back together. Now, these wire spring relays were built mostly by machine, and they were built in jigs. So they had these little holders to hold everything in place while you put it together, but I don't have the jig. So I kind of had to keep a pressure on it and use a helper or use my other fingers to bring new parts in and lock them into place. And if it was sort of this thing where if I ever released the pressure, the relay would just go boing, and I'd have to start all over again. So where are we at? Today I'm here and I've got my iron plugged in, and I'm gonna go wire wrap / solder the TS1 relay back into the marker, and we'll see how it goes. No, damn it. So why do a video like this? Well, a lot of people come here and they ask us, what do you have to do to keep these machines running? And the answer is, it depends. Most of the daily maintenance is just preventative, like, cleaning contacts, and in the panel, a lot of it's mechanical. in nature. And, you just do what you need to do to make the thing happy. And it's sort of hard to give a generalized answer to that question, because it depends. The number 5 crossbar is really a very robust machine. It doesn't require as much attention as the panel does. And they designed it that way. I mean, the relays, the wire spring relays, which are the basic things in that switch, are again, to overuse the word, they're really robust. And they'll just run forever, And they're resistant to dust. They each have individual dust covers. They're resistant to all that kind of stuff. But what we do see in that machine is the cost reduction towards the late 60s and into the 70s, where they said, those plug-in relays, well, they leak. All right, this is going to be a problem we're going to have to be focusing on for the rest of time, And in regards to the relay that I cleaned, the TS1 relay, do we have another one of those in storage? Probably. But I would rather not have to use a brand new relay from storage if I can clean and replace one that is otherwise working fine. We do have enough relays in storage, but again, they're not making them anymore. So in the interest of longevity, I'll put that one back in, because aside from the goo, it's going to be fine. And that's my overall philosophy with all of this stuff, is repair whenever possible, replace when absolutely necessary. And so far, that has seemed to work out really well for us. When they designed this stuff, especially the panel and the number 1, the older machines, they designed them before CAD, right? And before you could tell a computer, essentially, this is what the service life I expect out of this device is. If we talk about the iPhone that I'm filming this on, we all know the expected service life of this device is like 2 years before the battery just goes and becomes terrible, or before it becomes so old that Apple won't release updates for it anymore. Whatever. Androids are the same way. I don't care. And they designed them to be that way. They say, this is how long this customer is going to have this device before we expect them to buy a new one. So there's an element of planned obsolescence. And there was certainly an element of that in these switches too, but the design lifetime was closer to the 30 to 40 year mark. And they were designing from perspective of the upfront cost of this machine is so high that in order to make a profit on it, the telephone company is going to have to use it for so many years before they break even and can turn a profit. And that was certainly true in the panel. That was certainly true in the number 1. And the number 5 was, by all rights, one of the least expensive switches for what it could do. And that was really a triumph of engineering, of them saying, we can do more and also not make it, horrendously expensive. The issue really is learning the knowledge you need to keep these things running. And I've talked about this in other videos, and this is a constant thing I think about, is yeah, I can show you how the machine works, you being, general global you. I can show you how the machine works, but in order to understand what it needs, you just need to spend a lot of time around it and understand its moods and its feelings and how it tells you what it wants, because it's not always an alarm going off. It's not always a light flashing. Sometimes it tells you what it wants because it sounds funny. And learning about those sounds and about those other experiences that you can have is just like learning about a person, right? Where if you have a friend or a loved one, you know that they're not feeling well without them telling you they're not feeling well most of the time. And it's the same way with any machine, and especially with these machines. So, part of the reason I make the videos is to sort of spread the love and spread the knowledge, and hopefully other people will appreciate this too. So what's our next step? Well, once I'm done with my coffee, I'm going to go over to the test frame. Well, first I had to put the fuses back in the marker. I took the fuses out because Claire blew her first fuse when we were working on it. And then Astrid helpfully came over and, you know, took the 20 amp fuses out so we'd stop blowing them. And I blew one too because I was sticking my soldering iron back there around the battery feeder. So I'll put the fuses back. Then I have to go over to the test frame, and when we're there, I'll show you what I'm going to do. We'll test it, and we'll see what happens. Cheers. To see if this will actually work. And the way we're going to do that is by placing a test call. 015. And what we're going to do on the test frame is we're going to ask it to pick a specific frame and a specific trunk on that frame, and that will force that relay and the marker to operate. And if it works, call will go through. Frame select 0, trunk select 1. We don't care about a channel, we don't care about a junctor sequence or any of this stuff. So, will it work? Let's find out. Nope. All right, just for a sanity check, let's try trunk select 0. All right, that also didn't work. So that means that my test is probably wrong. Let's try the other marker. And the other marker works fine. There's my call. Trunk busy. Oh, sorry, yeah. Frame select always has to be 0. Trunk select can be whatever. Yeah, so the other marker works fine. And that likely means that I screwed up some wiring, which is unsurprising given how many things I had to take apart to get that relay out. So none of the TS relays are operating, but I found a bigger problem that is sort of my fault for not checking. See how this relay is off center here? Well, in the back there is the clip that holds the relay together, and you can't see it on video, but the clip has popped off the relay and is pushing on this relay next to it and pushing this relay over. So if I want to do this right, I really have no choice but to unwire this again and then make sure that I get that clip on correctly and it doesn't pop off. So regardless, it's not working. And now I'm going to unwire it again, snap that clip back on, make sure that clip is stuck, and then I have to rewire it. And now that I've taken the wires off twice, the wires have become so brittle that I can't reuse them. So that means I'm rewiring everything that leaves this relay, which goes to whatever else on these plates. That means I'm rewiring the whole plate. And that's not going to happen today. So we'll pick this up again tomorrow. Okay, it's day 2. We are back. And what we have to do now is make basically a net list of the TS1 relay, because I need to once again completely remove it, and now I have to replace all the wires because they're too brittle to reuse. So Astrid's looking at the drawing and building up a little list of every wire that leaves that relay and where it goes, so I can run new wires. And this is the clip that was broken, this guy here. This clip is what provides the tension to hold the relay together. So if you saw earlier in the video, it's this big sandwich of individual layers with these molded pieces at the bottom, and all of these layers have to go together, interlocking, and the clip wraps around it at the base here, holding it together. Now, while the relay was mounted in the frame, like that, the bottom part of the clip had broken off. Or not really broken off, it wasn't firmly mated to this steel here. So it kind of went boink, and these shoulders here had pushed against the next relay, pushing this over. I'm exaggerating it, but pushing this over like that. And there was really no choice but to take the relay out and reattach the clip, this time making sure that it's really firmly seated right there and right there. And just because now is a better time to check than later. Make sure it works. 48 volts. Yep, working fine. All right, so the relay's back in, and Astrid and I have verified all the wiring, got everything put back together. I do have to solder, which I'll leave a note to do that tomorrow, to solder the contact protection networks on. But let's go ahead and test it. We'll place an intra-office call, which is actually one of the harder calls the marker can do. And we will trunk select 1 just to prove that our TS relay works, and frame select O. Good. And this should work. Yep, worked. There you go. Call went through. So again, what I did here on this frame is the relay that we replaced had to do with trunk selection out of a maximum of 20. So the marker looks at 20 trunks at a time, and any trunk that's available will operate a TT relay, and the TT relay will operate the TS relay of the right number. And like I said, we replaced TS1, that's the relay we fixed, so I want the marker to force TS1 to make sure that we use that relay. And normally the marker will use whatever one it wants, but on the test frame I could tell it force trunk link frame O, force the trunk selection to trunk select 1, and I have to tell it that we're using frame group O because that's the only frame group we have, and that's mandatory to tell it that. So, and then we're doing, like I said, an intra-office call, which is the most complex operation we can do as far as marker juice goes, and then we'll hit it. That works. So, yes!